The intermolecular forces between simple molecules in compound A is weak. Hence, little energy is needed to overcome the forces, and hence lower melting point. Okay, so when explaining the high melting point and low melting point, make sure you explain for ionic compound why does it have high melting point? Because of strong electrostatic forces of attraction. And then for simple molecule, because of weak low melting point, because of weak intermolecular forces. Remember, there is no intermolecular forces in ionic compound. Hello, remember that. Intermolecular forces only in molecules, intermolecular, okay, in between the molecules. Okay, take note of this. Okay, in Haber process, when mixture of hydrogen, nitrogen, ammonia enters the cooler, NH3, the ammonia turns to a liquid, but other gases do not. What does this tell you about the boiling point of ammonia? Okay, this is a very common answer. Ammonia has high boiling point. It is wrong, surprisingly. Okay, by saying ammonia has high boiling point, ammonia is a gas, right? How can it have high boiling point? If it has high boiling point, it wouldn't be a gas. It would be a solid. So again, you have to be specific. It has higher boiling point than the other two gases. Yeah, this mistake is really specifically mentioned in the Marcus report. Very popular answer among the students. Okay, you have to be specific. What do you mean by high boiling point? It's actually higher boiling point compared to the other two gases. Okay, only solid have high boiling point. Gas cannot have high boiling point. Explain how the diagram shows that the overall energy change for the reaction is exothermic. Explain how the diagram show, this diagram show. Okay, and a lot of people will say, oh, because energy is given off during the reaction. You can't tell from this diagram. Or because energy is released during bond making, is because energy released during bond making is more than the energy absorbed during bond breaking. Okay, so you cannot tell from this diagram the energy absorbed or released or bond making or bond breaking. So only from this diagram. So how? You have to say the energy level, you have to mention the energy level of the reactants, because the reactants have more energy, higher energy level than the products, hence energy is released. Okay, there is nothing wrong with these two answers, just that you are not answering the question. The question say explain how the diagram shows. Okay, so how the diagram shows. From this diagram you can tell the energy level of the reactants and the products, and from there you can tell that it is exothermic. Explain in terms of bond breaking and bond making why this reaction is exothermic. Now, why this reaction? Now, the chemical equation is given to you. So you should not say, oh, reactants or the products. You should not mention the words reactants and products. Instead, you should mention hydrogen peroxide, water, or oxygen. Should not mention reactants and products. Because this reaction, the reactants and products are given to you. Okay, so all these are wrong. Okay, because energy released during bond making of what is more than energy absorbed during bond breaking of what bonds. Okay, because energy needed, what do you mean by energy needed? Just say energy released or absorbed. Okay, same thing, is less than the energy needed. Just say, you have to be specific. Remember, you have to be specific. Don't say energy needed, energy involved. You have to say energy absorbed or released. Okay, so the model answer will be because energy absorbed to break the bonds in hydrogen peroxide is less than the energy released when the bonds in water and oxygen are formed. Again, we shall continue in our next video.